Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will examine the graph of x equals y squared. So predictably, this is like y equals x squared, the parabola that goes like this, except we've switched the x's and the y's around. So x equals y squared is basically a parabola on its side. Now clearly, this is not a function. It fails the vertical line test. For example, I could draw infinitely many vertical lines that could hit this graph more than once. So clearly not a function. So how would we use the graph of this to graph something like this? X equals y minus 1 squared plus 1. Well, we can still look at the transformations applied to this graph to get this graph, but because the x's and the y's have been switched, these numbers don't do what they normally do. You see, normally a negative 1 in the brackets, if this was an x, it would shift the graph 1 unit to the right. It would shift x from 0, 1 unit into its positives. So for when we've switched x and y around, it's going to move y 1 unit into its positives. This number here actually has the effect of shifting the graph up by 1 unit. It doesn't work in the normal way because it's not y equals. This is actually not a function. So what about this plus 1 here? Well, normally when you add a constant at the end, it normally shifts the graph up 1. It moves y 1 unit into its positives. So what's going to happen when we switch the x's and the y's around? It's going to move x 1 unit into its positives. This number here actually has the effect of shifting the graph 1 unit to the right. So this turning point at 0, 0 is going to be moved 1 unit to the right, 1 unit up here at 1, 1. So the turning point's shifted here, but everything else is kind of the same. It's still going to go 1 across and 1 down, just like x equals y squared did, 1 across, 1 down. So that point would be moved 1 to the right, 1 up here. And this point at 1, 1 will be moved 1 to the right and 1 up. So it'll be here at 2, 2. Now I just join them up. Everything else will be the same. So excuse my bad drawing, but other than the shift 1 unit right, 1 unit up, x equals y squared, and this graph, x equals y minus 1 squared plus 1, they are exactly the same. Again, this is not a function. So similar to what we saw for circles, although x equals y squared is not a function, it's basically the composition of two functions. See, its top half, which I'll color blue, that is definitely a function, and its bottom half in red, that's a function as well. So if the blue is a function, that means I need to be able to write it in the form y equals. Well, what I can do for x equals y squared, I can just square root both sides. So the blue is the graph of y equals the square root of x, and this function down here at the bottom in red is y equals negative square root of x. So there's a very clear link between square root functions and the graph of x equals y squared. So let's say I want to graph this square root function here, y equals negative square root of x plus 4 minus 3. So because we've got the negative out the front, this will be the bottom half. It'll be the bottom half of a graph that kind of looks like this. So since I know how to draw graphs where the equation is of this form, I'm going to make this in the same form. I am going to rearrange this so that x is the subject. So the first thing I do is add 3 to both sides. Now I'm going to square both sides. Now when I square, I'm going to get rid of that negative out the front, but that's okay. Remember, because it was a negative out the front, it just tells me that I'm just looking at the bottom half of the graph. So I want x by itself, so I need to subtract 4 from both sides. So this graph here, this square root function, is the bottom half of this graph here. And I know how to graph in this form. So this is going to be the same as the graph of x equals y squared, but it's going to have a few transformations. So remember, the plus 3 inside the brackets, normally it shifts at left 3. It normally moves x's into the negatives. This time it's going to move y into the negatives. This actually has the effect of shifting it down 3. So normally when we subtract 4, it shifts the graph down 4. It takes y into the negatives. Now it's going to take x into the negatives. This -4 is actually going to move the graph 4 units to the left. So this graph here is the same as x equals y squared, except shifted 3 units down and 4 units to the left. So the turning point, which is normally at 0, 0, will be moved here and here to the point -4, -3. So remember, we only want the bottom half of this graph. It's going to go like this. To get another point to help us, this point that's normally at 1, -1, it will also be shifted 4 units left and 3 units down. So it'll be shifted to here, -3, -4. So otherwise, it'll just look like the bottom half of the graph of x equals y squared, and there we have it. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.